Alright, in question 2 we're given some shaded regions and we're asked to find a system of inequalities for these regions. So first we need to know what are the equations of the actual lines themselves. Well, let's start with this line here. So this line here has the same x value, and we can look at the x value because there's a point given here, and we can say that x is equal to 6 everywhere on that line. Also for the blue line, we could work out the y-intercept. We could see here that it's given here, the y-int, let's say, here, and the y value there would be 4. And now we can work, if we could work out the slope, we could have it in slope-intercept form. So we can use 2 points on this line. We've got 0, 4, and we've also got this point up here. So let's draw a right-angled triangle to make it easier to find the slope here. So we're going to use this right-angled triangle. The rise, we need to compare the y values. So 12 and 4, so that rise is 8. And then we look at the run, so we're looking at 6 and 0. That's nice and easy. The run's there 6. So the slope, if I can write it here, slope, we can say is rise, which is 8, over the run, which is 6. And that simplifies to, if we divide by 2 in the numerator and denominator, 4 over 3. So this equation here would be y equals the slope, 4 over 3 is the coefficient of x, the y-intercept is the constant term of that equation. So there's the equation of the line. Now we want the system of inequalities. So we have to decide from each of these equations which direction are we going. Well, from the blue line we can see it's underneath that. So the first inequality we can say is y is less than that expression there that we just found. For the x, well, we're looking at the values to the left, so that's lower. If we think about a number line, so x lower than 6. Oh, we should say too, this is a solid line, so these are also included, these values are included. We'll see an example be what the graph looks like when it's not included, so x less than or equal to 6. But this is not the region shown. The region we've got at the moment is everything to the left and everything under, so that would be this whole region here, and that's not exactly what we want. So we also have to have some more restrictions. We want it bigger than this line here. So the equation of that line there, well, the x values are all the same. So we also have x, let's say, bigger than or equal to 0. And also along here, we want it bigger than this line. So that line there is the x-axis, and the equation for that is y equal to 0. So all these values, we also want y bigger than or equal to 0. So I don't have enough room, but these should be written all in a vertical line. I've just written them across there to save some space. So there's our system of inequalities for that region. In part B, we've got something slightly different because we've already got the equation, and the difference is that this line, where it's a solid line on the graph, means these values can be included. So if we're looking for the values underneath that, it's simply a matter of writing that expression, but less than or equal to. Less than or equal to because of the solid line. Well, let's tidy that up. 2x plus 4. And for this other one, we've got a dotted graph. Now this is how we show that the values are not included here. So there's the expression. We're going to say y. Also, these values we want are underneath or less than this. So we should say less than minus 2x plus 4. Notice that it's not included here for the dotted line. Okay, so there's one more example here for this question. Let's go down to that now. So we have these two linear functions. We've got the expressions. So straight away, by looking at the graph, we can see that we're looking for a region in between these two lines. So we're going to be using the idea of compound inequality. But first, the expressions for both of these lines are different. We have them here in standard form. If we convert them to a slope gradient form, then that makes it a little bit easier. So let's make y the subject and say y is equal to, if we subtract 3x plus 5 is this equation here. And this one here is going to be y, same slope, minus 3, and this time minus 2. So the only difference here is the y-intercept here is at 5, and for this one the y-intercept's down at minus 2, so the same slope. So if we now go to write the inequality, well, we want the region underneath this line, so that's going to be y less than minus 3x so and also including it's a solid line, 3x plus 5. And here we have y, we want it above this line, so y above, bigger than or equal to, minus 3x minus 2. So what we're going to do is we're going to combine these two inequalities together. So we've got the y value in the middle, and we can say this is our notation for in between. So we can see that the smallest value here is going to be 3x minus 2. So 3 minus 3x minus 2. We can see this by reversing this inequality. We could rewrite this like 3x minus 2, reversing the direction of the inequality like this. So that might make it a little bit easier to see. And then the highest function here, the one higher on the y values, is minus 3x. Let's change that. Plus 5. And so that's our system of inequalities there.